Hey, welcome to TXAPA Live. I got Glen Dvorak with Hunter Industry, ex-TxDOT employee, engineer. So how long were you with TxDOT?
About almost 29 years.
29 years, and how long you been with Hunter?
A little over 8.
So we got both sides of the spectrum here. We got the TxDOT side, and we also got the contractor side. So today we're going to talk about ride quality for asphalt pavements. I'm Chuck Fuller. I'm with TXAPA, and we got Jim Warren at the helm, kind of controlling the TXAPA Live studio here. So Glenn, today we always talk about ride and how to achieve it and why do we need to achieve it. And I know that you've done a presentation in Laredo, and it was well received, great information. So we're going to kind of hit the highlights of your presentation today. So if you would, go ahead and kick it off.
Well, perfect. But thank you for the opportunity to be here.
Absolutely.
A lot of the information that I'm going to share today is my thoughts and how we've approached ride quality in the past, especially working in the Yoakum district and carrying it on while working at Hunter. So what we're going to do today is we're going to have a little agenda. We're going to talk about the design, the construction, and we also want to talk about milling types. The biggest focus that we're going to have is talking about design.
So earlier today, you said something about it's about 90% in design.
Yes.
And I thought that was a good statement that you made, that the construction side almost kind of takes care of itself, but it really starts in design.
That's right. Because if we don't have the tools, everybody's going to be disappointed if the ride's not there. It kind of goes hand in hand, but there's a lot of work that has to go into design to make a project successful.
Great. And before we start, we're going to use the word IRI quite a bit. And so for those of you guys out there in the audience, what does IRI stand for?
So International Roughness Index. It's a way of measuring the texture of the roadway. Okay. And it's a standard that we use to gauge how our ride quality is being measured.
Perfect, perfect. So, all right. Go ahead.
Let's jump into design, and what we're going to talk about is the scope of the overlay, the project IRI target, obtain the existing profile, identify tools, and look at fixed features. So the first thing we want to do is talk about the scope. Basically what you'll find is there's 2 pavement designs that'll come into play. Okay. One is by TxDOT's Chapter 6 of the Pavement Design Manual, which what it does, it references whether it should be a structural or non-structural overlay, and it gives some guidance. And then the other pavement design that comes into play is actually by ride quality. Okay. And so what we found in the past is if you don't evaluate the ride quality and understand what tools need to be in there, then you're going to be over your budget because you didn't allow for the ride quality tools. And so the project's going to get started off on the wrong foot. So both ways have to be evaluated, and that's how you start off the project on the right foot.
Okay, so we got So we had talked about Chapter 6 of the Pavement Design Guide. So how important is that for the individuals out there, for your designers, to understand that Chapter 6? I personally have never read Chapter 6, but since you're a TxDOT, you have Chapter 6.
Yeah, so it gives general guidance about each structural or non-structural overlay. Okay. The structural side is going to bring in FPS 21. The non-structural is more or less addressing maybe like some rutting or maybe some skid or some other type of issues. Okay. So it's a lower level. You don't have to run FPS. But with that said, typically a district will have a pavement design. All right. But then if they didn't evaluate it for ride and those tools need to be in there, they're going to be 2 different estimates. So you're starting off wrong from the start.
Just from the start. And I mean, that's unbelievable. So it really does land on the design engineer's shoulders.
It starts there, yes.
Starts there, great.
So let's move to the project RI. I've been in this a long time. Right. Okay. It's very difficult to understand until you do it over and over. So for me, every project that we designed, we had the same target. And because I can't design a road for a 30, I can't design it for a 40 RI or 70. So we always wanted to shoot for a 30 RI target. And so when you do that project after project, it creates that consistency, you get to understand ride quality a lot better, and it's going to make you understand how to use the tools.
And your contractor then becomes familiar with that, right?
Absolutely.
So so being in the Yoakum district for that many years, your contractor, after a series of projects, becomes familiar with it and understands what your expectations are.
Exactly.
So great.
Yes. So my slide kind of jumped around on me here a little bit, Chuck, but so the next thing we want to do to try to understand what ride quality tools we need to put in there is to evaluate the existing RI. What happens, You can go ride the RI on a roadway if it has an ACP surface, a seal coat surface, or even crack seal. Those numbers of the RI mean something different.
Right.
So, for example, let me get to a slide here. When you look at this particular one, you'll see the RI under the average of 140 down to 194.
Yep.
Okay. If that's an ACP surface, by rule, I know I'm going to do what one continuous lift will improve it 50%.
That's a rule of thumb, right?
That's correct.
Okay.
But if that's a seal coat surface, what that means, there's a lot of texture that your one lift will take out. And so you're going to have to evaluate them different. An ACP surface you can evaluate kind of off the existing RI.
Right.
But the seal coat surface, you're going to really have to go ride it to identify the localized roughness. We just don't have the tools available to do that.
I get you. I understand
Yes, sir.
that. That makes sense then. So the different surface types that we're dealing with definitely come into play. And so with the when you said the seal coat, so you have to really ride it. The design engineer has to understand that.
That is correct.
Okay.
Yes.
Good point. Good point.
So the existing RI value means different for the type of road surfaces that is out there.
Wow.
Yes.
Okay. So if you go back one more, I'd like to go see the dips and the bumps. So kind of explain that right there real quick for identifying our dips and our bumps.
So what I use this for is when I would go ride the road, seat of the pants,
Right.
a dip of 0.15 or a bump of 0.25, you don't really know what that means until you go ride it. So what I would do is I would take this just to kind of give me an idea of what I'm going to be expecting in the field. But the seat of the pants ride will really tell you if you need to address a localized roughness.
I got you.
And so what I would do is I would take what I found in the field. I always created this chart, and so the localized roughness identified in the field would be the blue areas on this chart.
Okay.
And so that was used two ways. First of all, I know I had to do something with it, but it helped me establish a quantity, because you have to come up with spot level up quantity. So this was a way that helped me come up with a quantity. The other thing though, if you look on the bottom of this sheet, you'll see a lot more blue that's collected. That meant I just need to do a continuous. It didn't mean for the whole project.
Just in that one area.
Just in that one area.
Great.
Yes.
Yeah. So I like that. I like the way that you had put that together and identified it, and then marked it on the map or marked it on the typical, so that you could determine your quantities.
Yes.
Absolutely.
Yes.
That's a good point. That's a great point for the designers to be able to get out and do that.
That's right.
So that goes back to the mere fact that the designers need to get out there and ride the project, as well as have that information in front of them.
Yes. So, Chuck, what we're talking about so far, there's no easy way to do this.
Right.
It just takes you riding the roads and understanding what it means to the seat of your pants, using the existing RI to the best that's allowed. But that's what I'm saying earlier. When you continuously do this, you'll get better and better at it and understand ride quality.
Great.
Yeah. So what we do with identifying the tools. So let's take the existing RI, it's an existing ACP surface. Say it has 120 existing RI.
Right.
Well, I know one pass of a continuous level up is just going to correct it to a 60. So is that what you wanted as your project target? For me, it was not. I wanted to have it down in the 30s. So we would add a continuous level up, or maybe go address localized roughness to clean it up even a little bit more.
So that brings up a great point. And when you talked about this was your expectation. So many times, area engineer or assistant area engineer has an expectation of a IRI that they want, the 30s for you guys, but then maybe there's not the tools given to be able to achieve that. So expectation and design kind of have to go hand in hand.
That is correct.
You have to put those two together. And again, I can't stress enough, this is just promoting the fact that the designers need to get out there. They need to get out and experience it, look at it, and to be able to know what they need to do to be able to achieve your 30. So that's, I didn't even realize that Yoakum's was a targeted 30.
Yes.
I wonder if the standard operating procedures for other districts have that. If they have
that'd be interesting.
Yeah, that'd be interesting to know.
Right.
Interesting, that'd be.
It was just a way to calm everything down, to allow me to be consistent at what I did.
Yeah.
And so it worked for me.
It makes sense. It makes sense. I mean, and again, your contractors knew what your expectations are.
Yes.
And if you're giving them the tools and you know the expectation, then they should be able to provide.
That is correct.
Okay, good point.
Yes. So what we do in design, the tools we set up will take care of construction. It makes it a lot easier, because if you don't have the tools, it's not going to be easy in construction.
All right, so here's some tools. Let's identify some of these tools.
So pavement repair is really not a tool, but what I put it in this discussion, Chuck, because it affects your IRI data when you get it, the existing.
Sure.
And so when we talked about the localized roughness, it shows up on the sheet, but when I go ride the road, I realize that it's pavement repair because I know I'm going to take care of it. So that's an area that will come out of my evaluation.
Right.
But pavement repair is definitely important just from the structural integrity of the road. Sorry, here, let me get back. Milling, regular or profile. So profile milling is something new over the last couple of years. Typically the regular milling of item 354, just take off maybe the distresses of the roadway. But profile milling can come in as a preventive maintenance tool when you don't have a lot of dollars. It can true up the profile. It can help address cross slope. For me, I'd rather address cross slope issues with milling because it gives us that true plane.
All the way across.
When you do it the level up, you're still doing a variable depth, and then you roll it and it's still a little inconsistent.
Inconsistent, right.
But it's a great way to address cross slope.
And I'm seeing that quite a bit more now in the bids, is that they're requiring a profile mill. So, and we want to make sure that you understand what a profile mill can do and what it cannot do. So
that's correct.
That's the deal. So
that's right.
Again, as designers, you need to be aware of that.
Right. And so if you do want profile mill, you got to put it in the general notes because we have to use our sensors and place sensors on the machine to do a profile mill.
Okay.
Absolutely. Spot ACP level up is a good tool, as we mentioned earlier. We showed some blue areas to identify and calculate a quantity.
Right.
Continuous ACP level up is one, and then of course your ACP surface.
Great.
So some of the other things that kind of get lost in ride quality is the fixed features of the road. What you're trying to do so far is put that paving machine in the best possible way to succeed. Okay.
Right.
And the way that I tell people is if it's got to be tied to something fixed, ride quality just got impacted.
Absolutely.
So let's talk about some fixed features. We mentioned a little bit about cross slope. What happens when you do ACP cross slope? You're going to lay a variable depth because you're placing it at that 2%, so to speak. But then when you roll it, it actually rolls down and you lose your cross slope.
Right.
So that's one that we need to look at. Tie into bridges. Okay, a lot of times they just give us that little 25-foot butt joint, and all of a sudden you're going to dive in, and it's very rough, and you're not going to forget that spot once you ride over it. So a good rule of thumb is to do 100 feet per inch. And the other thing I'd recommend with guard fence is do that transition before the guard fence, and then let's say we're doing a 2-inch overlay, then let's take 2 inches parallel to the guard fence. That way we can always tie into the guard fence, maintain that height.
Maintain the height.
Good tool to do, yes. Curb and gutter, okay, that's a big one.
That's our big one, that's the one.
That outside lane, especially in an existing curb and gutter that's been out there a long time, gets out of shape. The first thing I always like to encourage people to do, if you can do a full width mill, do that, but a lot of times what they'll do is set up a outside lane mill. The one thing you don't do is set up 7 feet of the 12 feet.
Right.
Because now I've got 3 points, I got 2.
You got to match.
Yes, and so I'm constantly touching that screed, and when you touch that screed, here comes localized roughness. It's coming in. So if you're only going to do a mill of the outside lane, make sure it's 12 feet or whatever the lane width is.
That's right.
Because that's the paver width that we're going to set up.
Good point. Again, you made the statement. We got to have the paver be able to do its job, right?
That's to do its job.
Yep.
Yes.
Yep.
And so a little technique we do on a paving the outside lane is we'll actually do a 1-foot screed extension. So we'll have our screed say set 11 foot with a 1-foot screed extension, and our screed operator will just do this
to match that.
I'm doing hand signals here, but to help match that gutter, where at least 11 foot is being paved from a ride quality standpoint.
Right.
And other contractors have some techniques. I just wanted to share that one.
Yeah, that's a great point. And again, here's the whole thing about all this, Glenn, is that, it sounds so simple, just we're going to do an overlay, or we're going to do a RMC, routine maintenance contract, we're going to do an overlay, and the expectation is to have a Schedule 2 or Schedule 1, and then even if you're given some tools, you have all these other items that you have to take into consideration to be able to achieve that.
Yes, sir.
And for that paver to be able to do its job, you're going to have to design this from the very get-go. And that's the thing.
We're still talking about design.
We're still in design.
Still in design.
Design, right.
Yes.
So, and again, I can't stress enough, we have to have a conversation about this, again. Keep going because the conversation is going to happen before we get to construction. But yes absolutely.
So some other fixed features that have to be looked at, and I probably missed one on that other slide, but Intersections.
Oh, yes.
A lot of times they don't want to mill the intersections. Well, when you pave through there, your screed guy has to match that.
He has to match it.
And once again, it's going to affect your ride quality. So some other ones that we talk about are curb only, manholes, and well, we just talked about intersections. Sorry about that. So here's a fixed feature that is kind of a favorite of mine. As you see, the gutter is extended out, but there's no gutter with the curb on either side.
Yep.
So every time we come to one of these, we have to stop. You bring your screed in, which is probably going to pull on that screed.
Pull the material
And
in.
there's a localized roughness. Then you go across front of the face of the inlet, and you have to extend back out. So there's always going to be some localized roughness.
Yeah.
And the other thing, Chuck, when you have an existing condition like a curb with the gutter only in front of an inlet, is the next overlay, we don't match that cross slope.
Right.
We get a little worse, and so the localized roughness
Gets
at
a
that
little
spot
worse.
gets a little worse. That
Well,
is
you know,
correct.
you show that inlet like that. That's and again, when you start talking about moving the screed in and out, you're changing the head of material. You're changing the screed up and down. Not only do you have localized roughness, but you can also just have a waviness through there. It just creates all sorts of issues.
It does.
And that's the reason why you have to talk about this before you get started. But yeah, absolutely, I got to take that into account during design.
So a curb is very important for the entire roadway.
Absolutely.
It allows us to have an opportunity to improve the ride quality. You bet. So another one we always talk about is manhole and water valves.
Oh, yeah.
What do you do with those things?
Yeah.
For me personally, I like to pave over them and then adjust up. To me, when we do it the other way, you're going to stop your paver. You're going to have to lift up. It's a lot of handwork. You're going to see, some segregation. In addition to the ride quality issue. To me, if the manhole is below and we raise it to match our hot mix later, that's the best technique.
And that's the technique that I would go with also. When I was running Raming paving, that's what my guys would do. We'd lower the manholes or water valves, pave over it, and then raise them up. That's exactly right. That's the easiest way to get the best ride.
Yeah.
Absolutely.
So that's kind of the bulk of the design.
Okay.
I mean, you and I just covered this in a few minutes.
Absolutely.
But this is actually a long time when you're in the design stage to go figure all this out.
Because there's so many different scenarios that you have to be able to identify and adjust to.
That is correct.
Right.
Yes, sir. So once you've done all that, and you know what your target is, and you've got your tools, now you want to go to TxDOT's ride quality's pay schedule in accordance with their guidance document. And one thing that we talk about, though, is if you're on an open road and you've got the tools in there, it's pretty well always going to be a Schedule 1 or Schedule 2. It's these city sections that we get into that it's a struggle because manhole water valve is going to affect it. Along the curb is going to affect it. You've got a lot more things that can affect it.
Right.
What is the appropriate pay schedule? And for me, we would do 2 different pay schedules even on the same roadway.
Oh, I got you.
Yes, because just because you can get a Schedule 2 on the inside lane doesn't mean you're able to achieve a Schedule 2 in the outside lane.
Right.
And so we want the appropriate schedule to be set up based on the condition that you're paving.
So multiple schedules for one project. You're going to have that.
Yes, sir.
And we talked about this just before we went on, is that the main lanes could be a Schedule 1 and the frontage roads or what have you might be a Schedule 3 due to the same reasoning.
That's correct.
Yeah,
absolutely. Yeah,
Good.
I mean, typically a main lane, they're going to put more emphasis on it than a frontage road.
Yep.
Then let's adjust the appropriate schedule for that and have 2 pay schedules in there.
Right.
Yes.
That's a good point. I mean, again, that's looking at this. Again, the curb and gutter, the non-curb and gutter, use multiple pay schedules. I like that. That's a good idea.
Yeah. So let's get into construction.
A little bit about construction.
So first of all, you want to look at the tools that have been set up. And when I say that, the inspector and the superintendent, paving superintendent, let's look at the plans, see what tools are set up, and then let's go figure out how we want to implement those tools.
Right.
Which means they're going to go ride the project. They're going to make sure they understand localized roughness, go take care of the pavement repair, get that all out of the way. But the localized roughness that's left is usually the toughest part to handle.
Right.
My message is to TxDOT would be have something set up in the plans to handle localized roughness. But don't be afraid to be flexible with the contractor that has the contract, because we all have paving skills that are a little bit different. We have different equipment. And so listen to the contractor on how they maybe want to address that localized roughness, because what works for them may not always work for me.
Right.
And so
right.
just be flexible when we have that conversation.
And the whole thing here is to have that conversation when? When do we have that conversation?
Before we start paving.
Before we start.
Before we start.
I told Glenn that since I've been here at TXAPA, I've had multiple individuals call me and say, hey, we got an issue with this ride. And I said, okay, well, let's talk about it before you guys start. And we've already done it. We've already paved, and we didn't have the conversation before. You got to have the conversation before at the pre-pave meeting and during your daily debriefs.
That's
Are we
correct.
achieving what we're expecting to achieve, and what can we do to achieve it?
That's correct.
So
Chuck.
that's the whole thing, is you got to have that conversation. And I like the fact that you said that you have the tools in there. Don't be afraid to utilize them, but also ride that project before you start, because that project might have changed when it was designed earlier.
Absolutely.
A lot of these
Yes.
projects have been designed a year ago,
Yes.
or maybe even longer, and now you're out there trying to achieve a Schedule 1 or what have you, and the roadway's in worse condition than it was when they did the design work.
And that's
How many
true.
times has that happened
Yeah,
to you?
absolutely, it happens.
So
yes.
it's really, really important to be able to discuss this at the pre-pave meeting, and preferably after you guys go out there and look at it, and then have the pre-pave meeting to discuss it.
Yep.
And then during the daily debriefs.
That's correct. So when you have the tools in there, you have the budget.
Right.
So when you have the budget, you can be flexible on how you manage those tools. Whether you want to lay the full 1.5 inch of a continuous level up, or do you need more spot level up, maybe need some milling. When you have the budget, it gives the flexibility of TxDOT to manage that project.
Right. Okay. And I see that you do have the daily debrief, talk
Yeah.
about it every day.
So that's right. What you talk about when you start the project is one thing, but now let's get paving. Because you can't pick up everything when you're just riding it. After you pave it, you can get a little better feel for it because you just made an improvement.
Right.
But yeah, each day, Chuck, go ride the project. You got the TXAPA all hands form that's very useful. Bring it into play. Don't just talk about the ride, talk about safety as well.
Absolutely.
I mean, we're always here about safety, and we need to include that in the conversation. But when you do that daily debrief, as you call it, that helps us manage as we keep going forward, because don't let a problem continue, because you can't fix it at the end. Our industry is a very expensive industry.
Right.
See something, say something early.
Fix it early. Right.
But our relationship is going to be much stronger when the tools are in there. And the other thing I found from my experience is how good our inspectors got at managing those tools, because they started to understand how to implement those. And the contractors that worked with us, they were willing to work with us. They wanted an RI of 30 if it could be achieved. So it was kind of unique how that took place over time, the ownership that would take place.
Yeah, absolutely. And again, I can't stress enough, Glenn said it several times, is that you got to have a conversation about it every day, and bring in safety. Like I said, is our traffic queue correct? Is our do we have a drop-off issue? Address the safety end of it, and then address transverse joints, and address joints in general, the joints ride. So that stuff, and it doesn't take that much. It just takes it's just a 10-minute conversation.
That's correct.
With the guy building the job, your superintendent, your foreman, and that inspector, or that CE&I, that representation for TxDOT, just takes a 10 minutes.
That's it.
That's it.
That is it.
I like it.
So, Chuck, we've talked a lot so far in a short period of time.
Right.
Okay. We probably need about 3 hours to really get into the details.
Right.
But what we talked about, though, is how important design is. And that's why I keep saying I think it's 90% of this process.
I agree.
And 10% of the field, because the success starts in design.
I agree.
It really does.
I agree.
One other area that comes into play that we wanted to talk about was milling.
Right.
I feel like there's been a terminology issue over the last several years, because now what we talk about is regular milling, we talk about profile milling, we talk about micro milling, we have diamond grinding. So there's a lot of different type of milling types available for our use. And so I just wanted to have a little conversation, if that's okay with you on this.
Absolutely.
Regular milling is item 354. It's the standard. If you want 2 inches, we just set down and go. But if we want profile milling, which is actually going to improve the profile, which you had talked about a little bit earlier.
Absolutely.
What happens there is a district needs to add general notes to the project stating they want profile milling. Now, don't just go set it up because you can. It needs to be used where it's necessary. And it's like where there's a lot of undulations. You will set up like a 2-inch mill, but what's going to happen? You're going to find that you're going to be taking out maybe 1 inch here, and you may be taking 2.5 inches out there, because you're asking the profile to be improved.
And the profile, you're talking about utilizing some type of grade control, correct?
Absolutely. You can use 3 sensors very similar. You can use a like what you do on a paper.
Paper, right.
It's those same type of sensors.
Right, right.
Yeah. So the difference between profile milling and regular milling, though, is going to be a couple things. Slower speed, because you got to let the sensors do this work. And we're not going to just take 2 inches off. We're going to vary, the depth is going to vary as you go across there. Micro milling is another one. That is very important for like thin surface mixes, because what happens, your ridge to valley depth, we didn't mention that yet, but that's what's critical on a thin surface mix.
That's what RVD means, right?
Yes, sir.
Okay.
So on a regular milling, it's typically about 8 millimeters. When you go to micro milling, it's going to be about 4, because that's very important on those thin surface mixtures, even microsurfacing, because it's a 1/2 inch. Some of our thin bonded friction coarse toms, they can be 3/4 or 5/8. So you do need a finer milling surface to allow them to succeed as well. Once again, if you want micro milling, I think it's a special spec by TXAPA. Just place it in your plan so we know.
And I did see micro milling on a couple of projects where it was just going to put a tom mix. It's like a routine maintenance contract. They're just going to put a 1-inch tom, but the existing roadway had a lot of crack seal.
Okay.
Had a ton of crack seal, and it's over-banded crack seal. And so they put an item in there for micro milling to take that over-banded crack seal off, and then before they overlaid, because they knew that it was going to reflect back up into the pavement.
Yeah. So not to get off milling, but when you mentioned crack seal, that's another thing that has to be addressed in design, because of how the bumps will come through.
Absolutely.
And yeah, you have to address how to handle crack seal.
And that's, again, you got to get out there and take a look at it, because some crack seal's been done correctly. But when it's over-banded, when we're talking about, when you're paying by the pound and the guy's out there, but, you have to address that. You have to address that before we overlay it.
Chuck, there's really only 2 ways. You're either going to mill it, or if you do a true seal coat, grade 3 or grade 4, either one, will be a good way to mitigate crack seal.
Good point, good point.
And so the other one we talk about is diamond grinding, which is used to correct localized roughness on hot mixes. It allows the RI to be run over it and get a fair RI value. So between regular milling, profile milling, micro milling, and diamond grinding, those are the 4 common milling practices that we now use.
Yep, I agree. And again, like you said, 354, as the new spec book is being rewritten, regular milling is just going to be at 354, so if you're going to do the profile and micro, that's a separate.
So profile is still going to be by general notes.
General notes, gotcha.
Yeah, they need to put that in item 354. Micro milling will probably be a special spec.
Gotcha.
And diamond grinding is a special spec.
Okay, perfect.
So here's just a picture of the different type of drums.
Right.
The reason why we put this up there, Chuck, is I can take a regular milling machine, vary my speed. I can actually meet a micro milling type texture that you want. I don't always have to go get a drum with a bunch of teeth. If a contract can achieve what you want with whatever type of miller, the key is that you only want that ridge to valley height of 4 or 8,
whatever it might be.
That is correct.
Talking about that, I like the fact that you brought that up, because you can have that drum with the million teeth on it, but the teeth might not all be new. They might not be rotating correctly, and what have you. Just because you have the micro mill drum doesn't necessarily mean that you're going to be able to establish that. That ridge to valley depth is really the thing that you need to take a look at, because you can have a regular drum with good teeth, good holders. They're working like they're supposed to be. You slow it down a little bit, and then you can achieve that same thing. Just like you said, I would prefer that to be in there than to utilize the micro milling with the drum like that.
I agree. If you just want a ridge to valley height of 4, put it as a general note and let the contractor achieve it. Yes.
So coming up, I know that we went through this fairly quick. I know your one in Laredo was 3 hours long, and Glen and I talked about this a little bit before we went on here. Is that Glen's willing to come to a district and do a presentation and really get a little bit more in depth. And again, I'll come also, to the district just to be able to support. But Glen's willing to do that to make sure that we get the word out. Is that durable, long-lasting pavement is going to start in design. That's the main thing. It's going to start in design. And if we have good riding roads, we have good IRIs on the road, that's what the traveling public expects. That's what the traveling public sees. That's what the traveling public wants. And if we've got a brand new roadway that doesn't provide that, the traveling public really is the one that gets, they're the ones that are affected by it. I know the districts are too, but it's so important to be able to get this right. And I know you're passionate about it. I'm passionate about all of it. And I know you're passionate about it. So we're offering to come to the district, do an in-depth presentation, and kind of really get into it, and then be able to ask questions and talk about, the different things that you experienced both at TxDOT and as the contractor, because you've been on both sides now. And I think that's real important. I mean, brings a plethora of information to the table, and I think that's what we need to do.
Yeah.
So if you guys want it, just contact us here at TXAPA, and we'll get it to Glen, and we'll try to get something scheduled up.
Yeah.
So with that being said, I know that we hit it really quick and really hard. Design, communication, debriefs,
Yes.
tools. Those are the items that we need to do a takeaway with this little presentation that we did. So,
Yeah.
Glen, you got anything else?
Once again, thank you for this opportunity, Chuck. What I will say in closing is the longer lasting payments also come in when you set up those tools. When it's time to pave that surface course, you're going to be paving a more uniform depth, which leads to better in-place air voids. Longer lasting pavements, a better ride. It all ties together and getting at least one more year of life.
Absolutely, and that's the whole purpose of it. And I'm glad that you brought that up. That uniformity of depth really does increase your air voids and gives you that chance.
Yes, sir.
So, absolutely. With that being said, Jim Warren at the helm and Glen Dvorak, again, appreciate you being here. That's it for TXAPA Live. We really appreciate it. Thank you, Glen.
Thank you.
All right.